Hey everyone, today we're going to look at this particular topic, Kadane's algorithm, right? So it is generally a dynamic sliding window algorithm, right? So sliding window, we know that it can be a fixed size window and it can be a dynamic size window as well. And Kadane basically have a non-fixed, that is dynamic size window, right? So let us assume that we need to work out on a sub-array problem, right? Wherein we are having a array in which there are certain elements. So suppose 3 minus 2, 1, 4 minus 5, 6, and 7. These are the elements that we're having in our array. And now we want to find out a window which is going to have a maximum sum, right? So we need to find out a sub-array. Sub-array is basically a part of array which is continuous in nature, right? We need to find out the sub array, which is going to be a maximum sum sub array. All right. So what it means is that you have to find out that particular sub array. It can be this one, or it can be this one, or it can be a complete array as well. But your task is to find that particular window, particular sub array, which is going to give you maximum sum. So if you will consider this particular window, you will get to know that the sum of this window is plus 1. So if suppose we have to consider a window out of these two windows, you will say that I'll like to choose only 3 instead of going for 3 and minus 2. Out of this window, out of these two windows, 3 is basically a window which is smaller in size, but maximum in sum, right? So just like that, we have to analyze all of the windows and then we have to come up with the solution which is going to give us the maximum sum. I hope the problem makes sense. And now let us go for selection of these windows, right? We started with 3. Basically, we're going to keep the sum that is highest in this particular point in a particular variable so that later on we can return that maximum sum, right? So suppose this maximum value is going to contain all the maximum sums that we are getting, okay? And then there is a current sum as well, which we need to update according to the window. So we started off with this particular window, which is having only one element as of now. We we looked at it and we said that, okay, let's make it current maximum, right? So if we are selecting this particular window, then the maximum is 3 and the current maximum is obviously going to be 3 as well. Then because we have to traverse the complete array, we have to look for all the possible windows, all the possible sums. So we said that, okay, let's go for another element. We just increased the size of this window, right? Now we want to go for this particular window. And the sum came out to be plus 1, right? So we updated our current sum because obviously now the window is a little bit longer. We have to say that now the sum of the current is 1. Do we have to then reinitialize or re-evaluate this maximum? Of course not. And the reason is that 1 is smaller than 3, right? So right now it is not going to update the max, but current sum is definitely updated because current contain the current window sum, right? Now the next option was to start after this point. The next option was to start a window from minus 2, right? Or to continue with the same window which we are having, which is this larger window. And we thought of that if we'll start with minus 2 window, then minus 2 is a negative number. It is going to give us some negative value, right? It is going to add some negative value into the future value. It could be anything. It could be 11, it could be 1, it could be anything, the next element. We thought of like, let's carry on this one. That is, let's carry on with this particular bigger window, right? So we started off from the first element itself. We're continuing with the window because right now the sum is maximum, right? Right now the sum is more than minus 2. So that's why we don't want to start with minus 2. We want to carry on with the previous window. So now the window has become this big, right? So it is containing 3 elements inside. And if we will evaluate the sum now, so now the current sum will become 2 because this 1 is also added into the previous part of the window. But if we'll compare with the maximum, then of course we can't change that maximum because out of all the windows that we have seen so far, this is smallest size window was the maximum, right? But we have to go again, we have to go forward and we have to see that maybe this value can change. So we increased the size of window and we made this window this big, right? So we are including 4 also inside the window. So you can see that the window is still carrying 3 with itself, right? It means that we have not changed the starting point of the window. And the reason is that till this point, we have not got any value which is less than 1, right? That is, it is not equals to 0, or it is not less than 0. So that's why we are not leaving these two values, right? We want to carry on with this because they are basically 3 and minus 2 together are adding something positive into the next values. So that's why we want to take them off with us to the next value as well. So now this was 4 and we added the current sum that was before with 4. So 2 plus 4 is 6, and obviously this window is now giving us a larger value. So we're going to update this maximum. We are saying that we have found out one of the larger value up until this point. Out of all the values, 6 is basically the largest. We want to carry on with that, right? Now, our question was that do we want to carry on with this window to the next level? And the answer is, of course, why not, right? So now the window has become this much. Now you will say that the current sum will become 6 minus 5, which is equals to 1. So should we carry on with this or not? The answer is the current sum now is 1, obviously. You have to carry on with this one. You have to include it into the next part because just think about it. If you will just leave this window, behind just because that there is a larger chunk of the sum that was reduced from it, you have to understand it in this way that this particular window when will be added with this left hand side window, it is going to increase the sum, right? It is going to increase the sum by 1, but it is going to increase the number. So that's why we want to go for taking this particular part as well. Now we are extending this window, and now the window size will become, it is going to start from this point, that is from the starting only, but it is going to go as far as these two positive values are concerned. So now 6 plus 1, the this particular part of the window is having a sum 1, but when it will be carried on to the further value, the sum will become 7, and we have got a new maximum which is 7. And when we will further take it away with us to the next value, will take it forward with the next value, then the sum will become 7 plus 7, which is 14, which is even bigger. So if you would have just discarded this part, the sum would have been 13. But because of that plus 1, the sum is now 14, right? So this is how you select the window. Whenever the window size is whenever the window size is less than 0, then only we discard that part, right? Then we discard that window, otherwise not. So this is the rule that we need to follow, right? And I hope that this makes sense as well. Now let us write a code for it and let's try to understand that how do we implement this. So basically the size of window is determined by two pointers. One pointer is going to tell us that from where are we starting this window, and the other pointer is going to tell us that where do we want to end this window. But we actually don't want to have these two pointers in action, right? We need only one pointer in action, which is going to tell us that, and these two variables, maximum and current, which are going to tell us that how much elements are we holding, right? Because right now the size is not a consideration. So let's start with the implementation part. So this is our array, and it can have, let's suppose these same elements are there. That is 3, comma minus 2, comma 1, comma 4, comma minus 5, comma 6, 7, right? So these are the values which we are having. And the algorithm goes like this, that first of all, we need to traverse this complete array for sure. So we need to have a loop, which is starting from 0 and going up until array.length, I plus plus. And then we need to have two variables. One is maximum, which right now is initialized with 0. And one is current, that also is having 0 currently. When we started off from the first element, we are saying that let's consider that the current window is having this first element, right? So current is basically specifying that what is the element or what is the sum we are holding currently, how much window we are selecting, right? So that is going to be shown off with this current variable. Now we're saying that this is current is inside this ARR, current is holding this ARRI, right? If at this point, if you think that maximum is smaller than the current, right, then you can update this maximum value. So this is one of the things. And how do we reselect the window? That is, how do we say that you have to just, uh, start a new window or something like that. So we say that if current value is smaller than 0, then you have to think of starting the window once again. And how do we start the window again? We make the previous sum 0, right? So a simple line you have to write here, that make current 0 if it is smaller than 0. What it means is that if current sum is equals to -3, right? And the next value is 4. So this -3 is going to just decrease the value, right? It is going to decrease the count further with -3, right? So that's why we just want to discard it. And how do we discard a particular window? By setting our current to 0. And whatever final value we're going to have, that is going to be shown inside the max, so that you can print out from this particular place. So this is system.out.print max. And currently the answer is coming out to be 7, which I don't think is correct, because we have not, written here that current equals to previous window plus ARRI. So that was the problem. Obviously, now we have rectified it. So yeah, so the final sum is coming out to be 14, and we have calculated it beforehand as well, and it was 14. So this is the simplest algorithm that you'll look for. That is Kadane's algorithms and algorithm, and there are many problems that are based on this problem that maybe you'll see in near future. We'll be having them uploaded on the channel, right? So if you like this video, you can subscribe to the channel, you can like the video, so that we can be motivated enough, we can remain motivated enough to upload more such videos for you people, and we could know that we're doing the right work.